Alright, so let's discuss the implementation of unique number 2 problem, right? So we'll write the code directly on hacker blocks. So let's start with the coding part. So first of all, we need read n, then we need to read all the numbers. So let's say the variable number stores the current number. So since we have to do it in constant space, we cannot store all the numbers using an array. So we are just going to use a variable result that is going to store XOR of all numbers, right? Or you can say this is the XOR. So let's read a number and let's update our cumulative XOR. And at this point now, the XOR is equal to A XOR B and all other numbers are cancelled out. Let's create a copy of XOR and call this value temp. And in the solution that we talked about, we said once we know this XOR, we will try to find out the position of first set bit from right. Okay, you can find position of any one set bit. I'm just taking the position of first set bit, and to do this I'm going to right shift this number unless I find the set bit. So let's see how I can do this thing, right? Okay, so while temp and 1, which means while the last bit is equal to 0, while temp and 1 equals to 0, what I will do, I will do temp equals to temp right shift 1, and I can say okay, let's assume the position is 0 and let's keep on incrementing the position. So after this loop, the last set bit or the first set bit in XOR is at position. So once we know this thing, what we can do next is we have to create a mask that checks if there is a set bit at this particular position in all the numbers given in the array, right? So mask can be created like this. I can say okay, 1 left shift position. So in my case position is 2, so 1 left shift 2 creates a mask like this, and then I can do a AND of this with 5, and if I get this result, okay, whatever is the number, ith number, ai and mask, if this turns out to be greater than 0, it means it has a set bit at that location. And what I can do, I can add this to result. So I can create 5, I can say result is initially 0, or I can say the number a is initially 0. I can do XOR with 5. Next time I find a number that is also 5, so I do XOR with 5. Okay, sorry, this thing 5 XOR 5, right? So 5 XOR 5 XOR 7, so this gives me the result 7, right? So let's create the mask now. So int mask equals to 1 left shift position, and for the numbers that we have stored, yeah, so there is now one problem. How do we iterate on the numbers again, right? So we will need one array to store the input. So yes, we have to take one array. So extra space would mean any extra space apart from the input space. Like we cannot create a frequency table, right? But yes, we can store the input. Okay, so let's make some modifications to the code now, because Without that, we can't solve this problem. Okay, so let's declare the array. And how big is the constraints? 10 raised to the power 5. So let's declare an array of 10 raised to the power 5. And we can say, okay, array of I equals to number. Now all the numbers are stored in the array, and now we will iterate on the array and find out those numbers which contain at a set bit at position, right? So find those numbers which contain set bit at position POS. So for int I equals to 0, I less than n, I plus plus. Let's see. If array of I contains a set bit, then doing an AND with the mask will give me a result that is greater than 0. And I must put round brackets here. If this is the case, then I can say, okay, let's assume the first number A is 0 and B is not known to us. B is also 0, let's say. Then I can say A equals to A XOR AI. Okay, let me give it some other name, X and Y. So A equals to A XOR AI. And this, after this loop is done, this will give me the first number A. The second number B, the second number Y can be written as the XOR. What is the XOR we have? This XOR, right? So Y can be written as XOR, and this should be X. So I'm taking the variables X and Y to store the two unique numbers. So this will give me Y because XOR gives me, so XOR basically stores the result. So XOR is 3 XOR 7. If the first number is 7, then I can do XOR with 7 to get 3. So yeah, let's see this code now. So we get Y, and then we have to print the smaller number first. So we can just cout min of xy followed by max of xy. So min and max are predefined functions in C++. You can use them directly. And let's compile and test our code. Okay, so it says temp equal line number 19. I don't see an error here. So maybe XOR could be a keyword as well. So let's say result. Let's compile and test our code. It is giving 0 and 1, which is not correct. Sorry, this should be equal to not equal to 1. While temp and 1, while the last bit is not equal to 1, we have to do position plus plus, right? So this was the mistake, and let's run the code now. So it gives 2 and 3. So clearly in this example 2 and 3 are unique numbers. So we can now submit. So yes, we have congratulations. We have solved one problem on HackerBlocks and we have passed the all the test cases. So that's all for this video, guys. I hope you would learn this approach.